Hi everyone, welcome to Mrs. Shin's class. Today, let's go over the scatter plot. Okay, let's talk about the scatter plot. What is it? So, scatter plot looks like this. It's lots of dots inside it. Okay, what it is, it's used to compare the two sets of numerical data. For example, age and height, weight and height. Something like that. We're comparing two sets of data. So they can be used to look for connection between the two sets, how much they're closely related. Okay, this connection we call it correlation. Okay, so this term is very important in the scatter graph. Okay, let's have a look at this example. I have 1, 2, 3, 4, 5, 6 students. Okay, 6 children measured their height and recorded their age. So for example, Anne, okay, she is 6 years old and the height is 112 centimeters. Whereas Phil, okay, is 13 years old and he's about 170 centimeter tall. Okay, then let's have a look. Who is tallest? Obviously, yeah, that's this person. Yeah, okay. Who is the youngest? We're looking at the x-axis, which is the age. Yeah, so in here, no one at 5, so the lowest is 6. We have 2 people. Ben and Anne. How much taller is Eric than Anne? Where is Eric? Eric is over here and Anne is over here. How much taller? So Anne is 120, Eric is 160. So we're just finding difference. Okay. Now, how much younger? So this time we need to compare on the x-axis, right? Nash is 8 and Jen is 13. So therefore, what's the difference? Yeah, 5 years old difference. Right. If Amina is 10 years old and 140 centimeters tall, okay, 10 years old and 140, okay, she would lie somewhere around here. There you go. Alright, so get all these datas, it's going to make like this, scatter plots, okay? Okay, now let's talk about the line of best fit. What is line of best fit? It's a line that shows the general trend of the data. Okay, so how you draw this is you have to draw a line in the middle. Okay, so I have same number of points above and below the line. Have a look at these line of best fits. Which one is the right one? Yep, 2, 3, 4 looks good, but which one is the best one? Yep, the line of best fit has to be number 3. Okay, the reason for that is it has to have the same number of points, top and the bottom. So above the line and below the line, I should have similar number of datas. Have a look at number 2. I've got more datas on the top, right, than below. And if you look at number 4, yeah, it looks okay. However, it has many little lines. It has to be one straight line. Okay, so number 3 is how you need to draw the line of best fit. So if you draw like number 1, 2, 4, or 5, it's going to be incorrect. Okay, how do you analyze a scatter plot then? You have to tackle all the 6 points. So you have to talk about whether it's linear, non-linear trend for the data, whether it's positive, negative association, okay, how strong, weak the relationship is, whether it's constant, non-constant scatter data, okay, whether you're outliers, clusters, and everything. Okay, so these are the key points that you need to tackle when you're answering the scatter plot. Alright, then let's have a look at this one. Scatter plot. Which scatter plot below shows a linear trend? There you go. See? Because if I draw a line of best fit, which goes in the middle right through, yep, this is a linear, and also E. Well done. Okay, all the others, it's not really a linear trend, right? Okay, let's have a look at this one. Which one is linear? Yeah, it's obviously linear, has to be a straight line, right? The first two, yes, but the last two, no. It's more like a curve. Okay, so we just identified what the trend line is, the line of best fit, and we identified whether it's linear or non-linear trend for the data. Okay, so next one, let's have a look at association. Right, first of all, positive correlation. If the x-coordinate and the y-coordinate both increase, then it's positive correlation. Remember for the linear graph, okay, if the gradient goes up like this from left to right, it's a positive gradient, right? It's the same concept. As x increases, so x increases, but y value also increases, right? So for example, this person, let's say x is age, like 5 years old, and the height is like 100 centimeter. Over here, let's say x is 18, age 18, the student, and the height is 180 centimeter. Yeah, so as the age increases, what happens? The height, yeah, the y value also increases, right? Along the line, we call it positive correlation between those two data. Negative correlation. Okay, this one, if you have a look at it, as x increases, what happens to y? Y decreases, right? Because if you look at 1 point over here, x is at 1, and the y is at 1, 2, 3, 4, 5, 6. Okay? However, as x increases and gets about, like, for example, 5, but what happened to y? 0.5, right? So therefore, as one increases, the other decreases. It's showing negative correlation. And also remember, in the linear equation, when you see a line going down from left to right, we had a negative gradient, right? So it's the same concept. We have negative correlation. Okay, this will be a good example. If you look at the age of your family's car and its value, you'll find as a car gets older, the worth will be less and less. So when you bought a new car, first 1 year old, yeah, it was valued a lot. However, as the year gets older and older, like it gets 5 years old, then the value will be less. Okay, no correlation. If you seem to find no patterns, okay, so it's neither going down or going up, but it's all over, that's called has no correlation. Okay, so this will be the example. So the shoe size of a baseball player and also their batting average. Do you think there's any relationship between those two? No, not really. Okay, so something like that is no correlation. That has no relationship at all. Okay, this is SUV, the car sales in US over the years. So if I plot the data, it's going to be like this. Okay, now you need to analyze the scatter plot. Right, what is the first one? Yep, the trend line appears to be linear. Okay, what else can you say? And the trend is increasing because it's going from left to right. Right, if it's increasing, what you have to give me evidence. Why is it increasing? How do you know that? As the years increase, the sales increase as well. So both increased. So therefore, since those two is increasing, what sort of correlation is it? Yep. So the sales and the years, they have positive correlation. Okay, so you need to answer every single thing that it's saying. It's linear trend, linear increasing trend, and having the positive correlation. As the years goes up, SUV sales also goes up. Okay, using this we can predict how much sales we will make in 2001 or 2002. Okay, this is another data set looking at time spent watching TV and time spent on homework. What do you think? If you watch more hours of TV, do you think you'll have, as much as time to spend on homework? No, I don't think so. So if you watch more TV, then you'll have less time to do homework, right? Let's have a go at plotting this. Okay, so on the y-axis, I put homework. On the x-axis, I put watching TV. Okay, they're also all in minutes. So if I plot them, what do you see? What things do you have to analyze? Number one, is it linear or non-linear? Yep, the trend appears to be linear. Okay, then is it increasing trend or decreasing trend? Yeah, it's decreasing trend. How do we know it's decreasing? Because as the hours, minutes of watching TV increases, what happens to the time on homework? Yeah, it decreases. So you need to say that. Okay. Therefore, is it positive or negative correlation? Obviously, negative correlation. Do you see how to analyze the scatter plot? Okay, that's great. Right, so far, we learned how to say it's linear or non-linear trend data, or whether it's positive, negative. Okay, right, what's the next thing that you need to mention? Is a relationship. What do I mean by strong relationship? Okay, if you have a look at the graph on the left hand side, what do you see with the dots? Yep, if I draw the best of line, okay, best of the line fit in the middle, most of the points, almost all the points, are very close to the line of best fit. Yep. If so, we can say the relationship is very strong. So the width and the length is very closely related. So very strong relationship. Right, let's have a look at this one. Look at the dots. What's the difference to the strong relationship? Yeah, so if I draw the line of best fit in the middle, it's linear, positive, going up. Yeah, okay. However, not all, not majority, but most points are reasonably close to the line of best fit. Okay, in this case, we're going to say, yes, the length and the chest has moderate relationship. Okay, or you can say, if it's moderate strong, you can say relationship is moderately strong. Oh, let's have a look at this one. Right, I'm going to draw the line of best fit somewhere in the middle. Okay, so I have similar number of dots, top and the bottom. Right, however, many points are some distance from the line of best fit. Okay, so I do have some distance. Okay, So in this case, I'm going to say weak relationship. Compare moderate, strong. Okay. People, you can say moderately strong, moderately weak, something like that. So if it's like in between, you're not sure which one to say, then you can say something like that. Okay, so therefore, relationship, we just covered what's a strong, what's a moderate, what's a weak relationship, right? Alright, in today's lesson, we covered what the trend line is, association, whether they have positive, negative correlation, and how strong the relationship is. Okay, so I hope you found this video useful. Now, I'm going to give you some questions. So have a go at answering all the trend line, linear, non-linear, positive, negative, strong, moderate, etc. By doing some examples. Okay, then I'll continue in the next lesson. I'll see you next time. Bye bye.